So for this problem, imagine you are a criminal. Specifically a bank robber. And from the bank, you stole 3 things: a statue, a mask, and an urn. And I should probably draw pictures to help you visualize the scenario. So now I've added pictures. Believe me, you have no idea how long that took to draw. And to make any scenario more realistic, we're going to add, of course, monetary and physical attributes to each of these items. The urn you want to steal weighs 15 kilograms and costs $30,000. Then the scary mask weighs 9 kilograms and is worth $16,000. And lastly, we have the urn. The urn weighs 8 kilograms and costs $15,000. So now I present to you a question. You didn't go to the gym enough, and you can only carry 20 kilograms. So how would you solve this? Well, one thing you might do, if you're in a hurry and you're about to be chased down by the police, is take the one that weighs the least and try to get as many things as possible, hoping that you'll make enough money from just the sheer number. Another opportunity might be to take the one that is worth the most, kind of ignoring what it weighs. Another choice would be to calculate the ratio between the weight and how much it's worth. That way you choose items as long as you can carry them based on the cost per kilogram, basically, the amount of money you're making per weight. It turns out all 3 of those solutions just don't work for this problem. The last one will work if you can take, say, half an urn, but for this, you don't really want to take half the urn. It's worth nothing unless it's all together, and same for the mask and statue. So you want to choose specifically which items to take. So taking the statue alone doesn't work. And it turns out the correct answer is to take the mask and the urn. So this is a surprisingly common problem in computer science, and I suppose if you're in a life of crime, it comes up often too. In computer science and economics, this comes up when dealing with kind of resource allocation and making choices about which items to choose based on how much a cost function and how much they're worth to you. So this is tricky to do quickly, and so we're not going to ask you to do it. I mean, you could enumerate all the possibilities, but that doesn't really scale once you get to, say, 15, 20 items. So what we're going to ask you to do is to write 2 functions that would help us check whether or not a given solution is correct. The first function we're going to write is called Heist valid. And this is going to return true or false on whether or not the items you are stealing is a valid thing to take away. We're going to ask if everything you're trying to steal is less than the total weight that you can carry. And then we're going to think about Heist total, which, given a list of things you're going to steal, returns how much all those items are worth. So Heist valid for the mask and the urn, because that's the correct answer, 9 plus 8 is less than 20, so we're going to return true. In the Heist total, we're going to add 16 and 15 and return that total. Pretty straightforward. But we're going to make it a little bit more tricky since we know how skilled you are, and we require you to give a one-line solution. And this doesn't really come up often when you're in the real world programming, but we're enforcing it here so that we encourage you to use list comprehensions and kind of think outside the box. So what are our inputs? We're going to take in 3 things. A dictionary that essentially catalogs all the things that we're able to steal. Each key in our dictionary is the name of the item that we can steal. And the value is a tuple where the first entry in the tuple is the weight of the item in kilograms, and the second entry is the monetary value of the tuple in dollars, although the units here don't really matter as long as we're consistent. We also have a limit to what we can carry. And lastly, we have a list of strings corresponding to the keys here of what we've taken. So let's do the first function. Since it's one line and we have to return something, it's probably going to start with a return keyword. So what we're going to do in this one line is add up the weight for each item that we've taken and see if it's less than the limit. And because Python's so awesome, this is pretty easy. So we're going to take the sum of a list comprehension that generates a list of the weight of each item that we've taken. This is going to be the name of the item, and that's how we're going to get the tuple out of the dictionary. And we just care about the first item in that dictionary. And for X and taken. So we're going to go through each string in the taken list, look up the value in the dictionary corresponding to that item, and take the first element in the tuple, which is the weight, and we're going to return that in our list. So we're going to take the sum of that, and we're simply going to check if it's less than or equal to the limit. And that's our one-line solution. Hooray! The next problem is going to have a very similar answer. In this case, we're going to go through each item in taken, get the tuple out of the available dictionary for that item, and simply sum up the costs. Here's the key difference. So this list comprehension returns a list of all the values of each item, and we're going to take the sum and return it. Those are our one-line solutions to each of those functions.